A website you visited 8 months ago may have migrated its entire infrastructure to a different hosting provider. The numerical address that was correct when your machine wrote it into that hidden folder is now pointing at a server that no longer hosts that site, or no longer exists at all. But your operating system does not know that. It has no mechanism to automatically verify whether the addresses it has stored are still valid. It simply trusts its own records. So when you try to visit that site today, your computer reaches into its hidden folder with complete confidence, retrieves an address that is months or years out of date, attempts to connect to a server that is either gone or unrelated to what you actually want, fails, waits for a timeout, and then, only then, makes the correct fresh request. That entire failed process takes time. Visible, frustrating, connection-killing time. Right now, at this exact moment while you are reading these words, your computer is lying to you, not in a way you can feel, not in a way any diagnostic tool will flag, not in a way your ISP will ever admit. It is lying to you through silence, through the things it is doing in the background without your knowledge, through the folders it has sealed away from your view, through the performance it is quietly stealing from you 1 millisecond at a time. You have been blaming the wrong thing for years, and by the time this is over, you will never look at your internet connection the same way again. Somewhere between the speed your internet provider promised you and the speed you're actually experiencing right now, something is taking a cut. A silent, invisible, systematically designed cut. And the answer to where that cut is happening is not sitting inside your router. It is not encoded in your Wi-Fi signal. It is not hidden inside your modem or buried somewhere along the cable that runs to your house. It is sitting inside your computer, inside a set of hidden system folders that your operating system has been deliberately concealing from you since the first time you ever switched the machine on. This is the conversation that the technology industry does not want to have. Because the moment enough people understand what is actually happening inside their machines, the entire business model of blaming connection, speed on external factors, on ISPs, on hardware, on signal interference, begins to collapse. According to the Speed Test Global Index compiled by Ookla, as of May 2025, the median fixed broadband download speed in Singapore reached 372 megabits per second. France crossed 315. The United States averaged 289. These are connection speeds that should make everything feel instantaneous, and yet, if you sat down in front of an average household computer on any of these networks and opened a browser, you would not experience anything close to that performance. The infrastructure is there, the bandwidth is there, something between the connection and your screen is consuming it, and that something has a name, a location, and a folder path. Let us start at the most fundamental level of how your internet actually works, because understanding what is broken requires understanding what was supposed to function correctly. Every time you try to visit a website, every single time, without a single exception, your computer must first perform a translation. The web address you type is human language. The internet runs on numerical addresses. A specialized system called the domain name system bridges those two worlds, converting the name you typed into the numerical server address your computer needs to make the actual connection. This translation process is called a DNS resolution. And under ideal conditions, it happens in tens of milliseconds, fast enough that you never notice it. But here is where your operating system made a decision that changed everything. Rather than performing this translation fresh every single time, it decided to remember the results. It created a private, hidden storage location deep inside your system and began recording every single website address it had ever translated, along with the corresponding numerical server address it received. The idea was logical. Why look something up again when you already have the answer stored? Pull it from the local folder instead of going all the way out to an external DNS server. Faster, more efficient, elegant in theory. And here is where it gets worse. Much worse. But that is merely the first layer. Because the hidden folder that stores these DNS records does not simply fill with outdated information. It actively corrupts. Conflicting entries accumulate. Records from applications, from background system processes, from browsers, from cloud services, from update mechanisms, all of them writing to the same hidden cache, sometimes overwriting each other, sometimes creating direct contradictions within the same file. Your operating system then has to parse through this corrupted mess on every single web request it processes. What was designed to add speed is now consuming it. Not by a small amount, but by a measurable, documentable, consistent margin that compounds across every browsing session you have every day. Now think about what that means at scale. Over the course of a normal day of internet use, an average person generates hundreds of DNS requests. Every email that loads, every web page that opens, every application that connects to a remote server, every video stream that initializes, each of these events triggers a cascade of DNS lookups. If every one of those lookups is being routed through a bloated, partially corrupted, outdated hidden cache before it ever reaches the actual internet, the cumulative drag on your perceived connection speed is enormous. Not theoretical, not marginal, enormous. The real story is that most of what people experience as slow internet is not about the connection at all. It is about the processing layer that sits between the connection and the actual delivery of content to your screen. And that layer is full of problems that your operating system generated, stored in hidden locations, and never once invited you to address. But the DNS cache is only the beginning of what your machine has been hiding. There's a second folder, one that operates at an even more foundational level of your network architecture, that most technology guides never discuss with appropriate depth. It is called the WinSock, catalog. And understanding it requires understanding that your computer's ability to connect to the internet is not a single, simple action. It is governed by a layered set of rules, protocols, and configuration data that sits deep inside your system and controls how every data packet you send and receive is handled. The WinSock catalog is the database that manages those rules. It is the internal registry of how your machine communicates at a network level, below the browser, below the application layer, at the raw infrastructure level of your connection. Under normal circumstances, the WinSock catalog runs cleanly and its entries remain consistent. But it is extraordinarily vulnerable to corruption. Every time you install a new piece of software that touches your network settings, a VPN client, an antivirus program, a network utility, a peer-to-peer application, that software has the ability to write entries into the WinSock catalog. Some of these entries are added correctly and cleaned up properly when the software is removed. Many of them are not. They linger in the catalog long after the software that created them is gone, creating what network engineers refer to as protocol conflicts, situations where two or more entries in the database are giving your system contradictory instructions about how to handle certain types of network traffic. The result is not a simple slowdown. The result is erratic, unpredictable, maddening connection behavior. Your browser loads some sites instantly and refuses to load others. Your connection speed tests high, but your actual experience is poor. Your machine shows full signal but cannot complete certain requests. You reboot, the problem seems to go away, and then it returns an hour later. None of this points to your router. All of it traces back to a corrupted internal network configuration database that you cannot even see without navigating into system directories hidden by default. According to informed sources in enterprise network administration, WinSock corruption is one of the most consistently misdiagnosed network problems in consumer computing. The symptoms are real and severe. The cause is completely invisible under normal operating conditions. And the fix, a single command that completely rebuilds the catalog from scratch, takes less than 30 seconds to execute, but resolves issues that users have sometimes lived with for months or even years. Think about what that means. There are people right now who have replaced their routers, upgraded their internet plans, bought new computers, and called their ISP repeatedly, all because a corrupted hidden database inside their existing machine was silently sabotaging every connection they tried to make. The problem was never outside the house. The problem was inside the operating system, in a hidden location that nobody told them to check. This is not the only way your system bleeds speed behind your back. There's a third hidden accumulation that operates at the application layer, and it involves a folder that your operating system buries so deeply within your user profile directory structure that the average person could use a computer for a decade without ever discovering it exists. It is called the iNet cache, and it represents your system's private collection of every web component, every script, every image, every style file, every cookie fragment that your browser and your Windows-connected applications have ever downloaded from any server, stored locally for the purpose of loading that content faster the next time it is needed. The logic, once again, is sound. If you have already downloaded a website's logo, there is no reason to download it again every time you visit. Pull it from local storage instead. Save the bandwidth. Save the time. The problem is that web content changes. The logo you cached a year ago may look different today. The script file you stored 6 months ago may have been updated, deprecated, or removed entirely. The iNet cache folder does not automatically verify whether its stored files still match what the server is currently serving. It simply holds on to everything it has ever downloaded indefinitely until it either runs out of allocated space or something manually clears it. And as this folder grows, and it grows constantly and visibly without any notification, it creates increasing conflict between the stale data it contains and the fresh data that servers are trying to deliver to you. Your browser receives new content from a server, but your system tries to reconcile it with an older cached version that no longer matches. The result is slower loading, rendering conflicts, and in some cases outright errors that look like connection problems, but are actually local cache conflicts. Users who have navigated into this folder after years of uninterrupted use routinely find it containing data from thousands of sources. Cached files from websites they visited once 3 years ago, script components from services they have long since stopped using, multimedia fragments from applications that have been uninstalled from the machine entirely. The iNet cache folder is, in practice, a digital archive of every web encounter your machine has ever had. most of it now serving no purpose other than to occupy space, generate processing overhead, and create opportunities for conflict with the current state of the internet. But here is the layer of this story that genuinely reframes everything, the one that most technology content stops short of addressing, because it implicates the operating system manufacturer directly rather than external factors. Your Windows installation contains a feature called delivery optimization. When this feature is active, and it is active by default on Windows 10 and Windows 11 without any notification or explicit consent from the user, your computer is used as a distribution node for Windows Update files. Your machine downloads update packages and then uses your internet connection to upload those packages to other computers, sometimes on your local network, and in certain configurations, to completely unrelated devices anywhere on the internet. Let that land properly. Your internet connection, and the one you pay for every single month, the one you depend on for work, for communication, for entertainment, for everything digital in your life, is being used by your operating system to serve software updates to strangers. The cached data for this process is stored in a hidden subdirectory of your Windows folder, and the upload traffic it generates runs in the background without any visible indicator in your normal system view. When your connection feels inexplicably slow during what should be normal usage, delivery optimization is among the most common culprits that no standard troubleshooting guide will point you toward. The cached folder that stores delivery optimization data grows steadily as your machine participates in this peer-to-peer update distribution network. It consumes disk space, generates disk activity, and occupies upload bandwidth. Now let us bring all of this together into the practical reality of what clearing these hidden folders actually accomplishes, because the mechanics of the solution are as important as the mechanics of the problem. The first intervention is the DNS cache flush. This requires opening a command prompt with administrative privileges and executing a single command, ipconfig, followed by the flush DNS parameter. What this command does is instruct Windows to discard every single entry in its DNS cache, every stored website address, every recorded translation, every cached lookup result, both the accurate and the corrupted ones, and begin rebuilding its database entirely from verified live server responses. The result is a DNS system that is no longer navigating around outdated records or resolving conflicts between contradictory entries. It is working clean, with fresh information, querying external servers properly, and caching only what it verifies in real me. Users who perform this flush on machines that have not had their DNS cache cleared in months consistently report immediate improvements in the responsiveness of their browsing, not because their connection speed changed, but because the layer mediating between their connection and their browser was finally operating without the accumulated interference of months of unverified stored data. The WinSock reset is the second intervention, and in many ways the most structurally significant. Executed through an administrative command prompt using the netsh WinSock reset command, this operation completely dismantles the corrupted network protocol database and signals Windows to rebuild it from its original baseline configuration on the next restart. Every conflicting entry, every legacy rule left behind by uninstalled software, every protocol configuration written by a VPN or security tool that no longer exists on the machine, all of it is discarded. What replaces it is a clean, consistent, correctly structured WinSock catalog that gives your network adapter unambiguous, conflict-free instructions for handling data traffic. The improvement in connection stability following this reset is frequently dramatic. Not a subtle performance improvement, but a qualitative shift in the reliability and consistency of the connection itself. The temp folder cleanup addresses the systemic processing overhead that accumulated staging debris creates across your machine's performance pipeline. By navigating to both the system-level temp location and the user-level location, selecting all files, and removing them, you are liberating your disk activity from the burden of managing thousands of files that no active process is using, or needs. This has a direct relationship to network performance because your system's ability to handle incoming and outgoing data packets efficiently depends on the overall processing headroom available to your CPU, RAM, and storage. And every unnecessary file your system is managing is consuming a fraction of that headroom. Clearing the temp folder does not just improve application speed, it clears the pipes, in a very literal sense, through which your internet activity flows. The init cache cleanup requires enabling hidden file visibility in your File Explorer settings, and then navigating through your app data directory to locate and clear the folder. The effect of this clearance is most visible in browser behavior. Pages that were loading stale versions of sites, or experiencing conflicts between cached and live content, suddenly begin rendering from fresh server data without the interference of outdated stored components. Sites that seem to load slowly, not because of connection speed, but because of local rendering conflicts, begin responding at the speed that the connection actually supports. Finally, adjusting the delivery optimization settings accessed through Windows Update settings and the advanced options within delivery optimization specifically, to restrict update sharing to local network only, or to disable the outbound sharing entirely, reclaims the upload bandwidth that your system has been quietly redistributing to other users' machines. Combined with clearing the software distribution folder of accumulated delivery cache files, this intervention stops the background bandwidth drain that has been operating without your awareness and restores your full upload capacity to your own use. According to informed sources who study real-world network performance on consumer hardware, the combined effect of these 5 interventions on a machine that has never received this kind of maintenance produces results that consistently surprise users who have come to accept degraded performance as the normal state of their connection. The speed was never gone. It was being consumed. The consumption was happening in hidden folders that your operating system designed you not to see. The question we're sitting with, the one that does not resolve cleanly even after you've cleared every folder and reset every configuration, is why this state is the default. Why does an operating system used by over 1 billion people worldwide establish hidden caches that corrupt over time and degrade network performance, store them in locations inaccessible to the average user, and provide no automatic maintenance mechanism to prevent the accumulation from becoming a problem? Why is the delivery optimization feature, which uses customer bandwidth to distribute Microsoft's own software, enabled silently and by default? Why does the WinSock catalog have no built-in integrity verification that would flag and self-correct corrupted entries before they begin affecting connection quality? These are not rhetorical questions. They have structural answers that involve the relationship between operating system design, hardware sales cycles, and ISP business models. When users believe their internet is slow due to factors outside their machines, they upgrade their service plans. They replace their routers. They buy new computers. They remain customers of their ISP instead of switching providers. The perception that internet slowness is an external hardware or infrastructure problem rather than an internal software maintenance problem serves multiple industry interests simultaneously. The hidden folder is not just a technical artifact. It is a structural feature of an ecosystem that benefits from your not knowing where to look. Your internet speed has never been fully yours. Not since the first day you switched on a computer that was designed by default to accumulate, to degrade, and to hide the evidence. The performance you have been experiencing is what remained after the system finished taking its share. Through its DNS accumulation, through its network catalog corruption, through its background bandwidth consumption, through its layers of obsolete cached data. The speed that is rightfully yours has been sitting in a different folder, a hidden one that was always there, always accessible, and always waiting for the day you finally decided to go looking. Today was that day. But here is what you need to understand as you close this. Clearing these folders is not a permanent solution. It is a maintenance cycle. These folders will begin refilling the moment your machine reconnects to the internet. The DNS cache will start accumulating new records within hours. The temp folder will receive new deposits within days. The iNet cache will grow with every browsing session. Which raises the question your operating system has never answered for you. If these accumulations are this damaging, and if their growth is this inevitable, why was periodic maintenance never built into the system automatically? And if that question makes you uncomfortable, if the idea that your operating system generates its own interference and hides it from you in order for you to go on paying for upgrades that never fully solve the problem makes you want to look more closely at everything else your machine is running without your knowledge, then perhaps the more important conversation is not about the folders you just learned to clear. Perhaps the more important conversation is about all the ones you still have not found. What else is running on your machine right now? What else is consuming your performance in silence? What else is your operating system hiding? Not in plain sight, but 3 directories deep, behind a hidden file visibility setting, in a folder with a name that tells you nothing about what it costs you. That question does not have a clean answer yet, but it is the right question to be asking.